alternating current, alternating current. This is for class 12. For class 12. Now here, first is that a purely resistive circuit. This is the resistance and AC supply is connected to it. So here an AC supply connected to it, and here this is the resistance R. So the potential difference V is equal to Vm sine omega t, because it is a Vm sine omega t, because this is a sinusoidal wave. So Vm sine omega t. Now AC current. Now here, according to Kirchhoff's law, the total potential will be 0. According to Kirchhoff's law, the total potential will be 0. So this is V is equal to IR. So summation of total potential will be 0. That is V is equal to IR. Now here V, that is Vm sine omega t by R is equal to I. So here your Vm by R, this is equal to Im. So your I will be equal to Im sine omega t. Now here the point is, why we did not use the Ohm's law in this case. We used the Kirchhoff's law, that is summation of this, in this loop the summation of potential is 0. We do this summation of potential as 0. Why did not we use this Ohm's law? Because in Ohm's law, you remember that it is actually used for DC current. Ohm's law that is used for DC current. Remember that. So here we have used the Kirchhoff's law. Such type of basic knowledge or basic things which must be clear with you. You don't go just this is given here in the book, so I have written this here. This is the summation of this according to Kirchhoff's law. Summation of this potential is 0. So we have taken this. But why? You have to ask the question: why did not we use the Ohm's law? Because Ohm's law is used only for DC current, not for AC. Here, because the current is fluctuating. It is no doubt it is not asked in your examination or any competition, but the knowledge you must know. Then only everything will be clear for you. Only memorizing it, it is written in the book, so it is the truth. That is not the thing. You have to ask questions, such type of questions. So here I is equal to Im sine omega t, and what we have find that here this is V and I. Your V is equal to Vm sine omega t, and your I is equal to Im sine omega t, and there is no phase difference. There is no phase difference. Here we see that there is no phase difference. Since there is no phase difference, so your phasor diagram and first of all your this V is equal to Vm sine omega t. It will be, the graph will be this will be your graph, and this is for V, and for I it will be this is for I, because they are in same phase. This is for I. So now you can again ask a question. What is the question? Why the graph of I is lower than that of V? Why? why the graph of I is lower than that of V. Why? So again, why the graph of, so here you find that I is equal to Vm by R. So value of I is automatically less than that of the V. So your graph goes little bit down than V. And your phasor diagram will be, this one. This is the V and this is the R, your phasor diagram, making an angle omega t with the x-axis. This will be your phasor diagram. Now let us go for the power. Here your power is equal to I square R. So here this is I square R, but here you see we have to take average power. I means I n sine omega t into R. We have to take average power because it is fluctuating and we are considering it for one cycle. So we are going to take the average power. So here your I square R, here, this is your average power. So again, if you little bit of trigonometry, average power, that means we are going to take the average of this. So little bit of, you can represent this also like this. This is the average. So your average power, here you see that little bit of trigonometry. This is I m square sine omega t, that means 1 minus cos 2 omega t by 2 into R. So omega t, this is 1 minus 2 cos omega t by 2. Let us say 1 cos omega t by 2. So here you will find that the average of this cos omega 2 cos omega t will be 0. So your P average will be I square n R by 2. This will be your P average. That is the power average you are going to get. This is your power average you are going to get. Remember, this is your power average. Because for one cycle the average of cos theta is 0. So you are going to get, this is the average power. You are going to get, this is the average power. Now here your this AC power this AC power can be also expressed in DC power. So to express AC power to DC power, we require IRMS, that is root mean square. We require root mean square. See the important point. You can express this AC power to DC power. You can express this AC power. You can express this AC power to DC power. You can express it. So to express this AC power to DC power, that is, this can be done by IRMS. So IRMS. So that means here your IRMS, that is IRMS, that means this is what root I average square, root I square average, sorry, this is root I square average. So root I square average, here this is your I square average, this is it, because in average power this is your I square average. So you are going to get, that is root I square m by 2. This is your I square average, root mean square. So here you are going to get Im by root 2. This is the IRMS, means this IRMS is equivalent to your DC current. Your IRMS is equal to the DC current, and this is equal to Im by root 2. So here again you can see that your V is equal to IR, that means Vm sine, you can say Vm, let us say Vm is equal to IMR. If you divide it both sides by root 2, Vm by root 2, that is Im by root 2 into R, so this is V is equal to IR. This is what we say IR. Capital R, here. So here that means this is VRMS, IRMS, or that is the equivalent DC current. IR, that is the equivalent DC current. So V is equal to IR. So this is the VRMS, this is the equivalent DC current. This is the equivalent DC voltage. This is the equivalent DC voltage. V is equal. So now we are able to express in, this is equivalent DC. So we are able to express this in Ohm's law. V is equal to IR. Remember, so we are able to express this V is equal to IR. So the most important thing, that 220 volt you are getting here in your house, 220 volt, this volt, this is VRMS. That is, this V is VRMS. This V is VRMS, and this is equivalent to your DC voltage. This is equivalent to your DC voltage. See here, this is IRMS. This is equivalent to your DC current. And now here you see that since your this IRMS, so VRMS, so this is the DC equivalent of AC current. This is the DC equivalent of AC current, equivalent DC. So now I am able to write V is equal to IR, and this is so I am able to express this in Ohm's law. So such type of basic things you must remember, and the voltage you are getting in your house, that is VRMS, and that is equivalent to your, that is DC voltage. So here already it has been told that AC power can be expressed in DC power with the help of IRMS, that is I root mean square, that is IRMS is equivalent to the effective current, that is equivalent to your DC current. So these are the basic concepts. Here it is such type of things are not going to ask in your exam or in your any competition, but you must have that you must ask why here we are not able to use this Ohm's law, but we have to use this Kirchhoff's law. Why we have used this Kirchhoff's law? Why? So such type of things, because V is equal to IR, this can be expressed only in Ohm's law. So I have tried to make it as much clear as I can, and here I is less than V, because here your I value is less than V, Vm divided by R. So here my concept is to give this not for to gain likes or subscribes from you. My aim is not to get, I am uploading all these things not to gain this likes or subscribe. I just want to tell you, the students, the basics you must know, the main basics, your pattern of study. You must change your pattern of study. You must not, without what the drawing given in your book, you must have a deep knowledge of that drawing. Why such thing is done? Again, let us take. You will find that you will find in your book that everywhere where there is a magnetic field, always it is expressed as cross into the field or out of the field. But your electric field lines are always expressed in plane. That is, your electric field is always expressed in plane. Your electric field is always expressed in plane, but your magnetic field is expressed as cross or dot, that is into the plane of the paper or out of the plane of the paper. Why such type of drawings are being done? Why there is such type of drawings? You must have such clear concepts of this drawing. So I am doing this all this not to gain likes or to get subscription. I am trying my best that the basic knowledge, the basic thing, the drawing, why they have used this Kirchhoff's law, why the graph of this V is less than this, why we are here we are able to use Ohm's law because this is equivalent to your DC voltage. So then only we are able to apply this Ohm's law. So such type of basic things, this must be clear with you. This must be clear with you. Why your magnetic field lines are in your book everywhere it is drawn either into the plane of the paper or out of the plane of the paper. Why electric fields are drawn in 2D planes? Why? Such type of questions you must ask. Such type of things must be clear with you. No, not only solving the problems. This is a mechanical way. You solve the problem if you have a good knowledge of this theory and every formula and the units, any type of questions, you can correlate it and you can solve it. That means then only it will be interesting for you. There will be no need of making notes. So most of the students are of the habit that they want a note. They do not want to develop their own way. They want the notes so that the notes is ready and they will memorize it and they will write in your final exams. And this is not the way of studying. So that are the main. So I am making all these videos not for to gain likes or to get subscription, only to clarify your doubts, how to study, the importance of this chapter. Now I am going to my next circuit, that is the next circuit is this. Now it is connected with an inductor. Here this is connected with an inductor. Here this is connected with an induction coil. Your AC, this is connected with an induction coil. So how this induction coils, it also creates a resistance because of this fluctuating current. You have learned that because of this fluctuating current, here your magnetic flux is changing. That means your magnetic field is changing, your magnetic flux is changing, and due to the change in flux, an induced EMF is developed here, and this direction of this induced EMF, as per your Lentz's law, is opposite to one which has created it. Its direction is opposite to the source, so it almost acts like a resistance. So here again applying your Kirchhoff's law, your total potential will be 0. So this will be equal to, this is V, and so V will be equal to minus L di by dt. So this will be minus L di by dt. So here V by minus L, that is equal to di by dt. So V is equal to minus Vm sine omega t by L is equal to di by dt. This is di by dt. And now you integrate it, that is minus Vm sine omega t dt by, this is Vl, you are going to get di. Now here you integrate it, you are going to get minus, this is Vm L, this is minus cos omega t by omega is equal to di. So this will be equal to Vm by L omega cos omega t, this is we integrated uh, uh, c plus is equal to I. So here cos omega t, that will be c plus Vn omega L cos, that is sine d minus L di dt. One, the potential here, potential, so the total potential is 0 here, so this will be plus, so this will be plus, so this will be plus, and here this will be your minus, so this is minus, so this will be minus, because here total potential is 0, that means V minus L di by dt will be 0 according to your Kirchhoff's law. So here this will be V is equal to L di by dt. So here we can write cos omega t means pi by 2 minus omega t is equal to I, and C plus Vm, this is omega L, omega L sine, that will be equal to omega t minus pi by 2, that is equal to I. Now about the integration constant, in your book it has been given a beautiful explanation about this integration constant. It has given you a beautiful explanation. Here you see I. This is a their C, because I is equal to, so I its dimension is of current. So the dimension of this C is current. But we see that your V is equal to Vm sine omega t. Vm sine means V is oscillating. I is equal to Im sine omega t. That is also oscillating. So there cannot be a quantity which is independent of time. So there cannot be a quantity which is independent of time, because I is oscillating, V is oscillating. That means they are dependent in time. So this is independent of time. So such type of constant, there cannot be any constant which is independent of time. So there C is 0. So your I is equal to Vm omega L sine omega t minus pi by 2. So this is your here where omega L is equal to XL, and this is called as inductive reactance. This is called as inductive reactance. This is called as inductive reactance. So here this is called as XL, inductive reactance. So here your I will be is equal to Vm by XL. This is I. This is Im, sorry. Im is equal to Vm by XL. So here you find that here V, your V is, this is V is equal to Vm sine omega t. So here you find that the current between the current and V, there is a phase difference of pi by 2. That means I lags V, that means I lags V. I lags V, that means your graph will be, this is your V, this is your V, and I will be 190 degree lagging. So here this will be your I. So here this will be your I. So this is V and this is I. So in your phasor diagram, it will be like this. In your phasor diagram, so this is your V, and this is your V, and this is your I. This is your I, which will be lagging by 90 degrees. So here this will be your phasor diagram. So here this is your this is about your inductance. Now again here your this average power here is equal to your average power is I square R. Your average power I square or this average power. So here what happens, your I is this is this will be here this average power, this will be I is your here I am sine omega t minus pi by 2. So this will be cos minus common minus cos 90 sin 90 minus theta, this will be cos theta. So square, this will be equal to average is I square cos square in omega t r, cos square omega t r, your average here. This will be your average because your current is I is equal to I am sin omega t minus pi by 2. Your minus common, so the minus sin, and now again sin 90 minus theta, this will be cos theta, and square of this cos theta, and your square of this cos theta, square of this cos theta, this square here. For a cycle here, this will be 0. So here your average power is 0. In inductive circuit, your average power will be, in inductive circuit your there is one thing before going to this average power here, before going to this average power, let me do one thing before going to this. Your P is equal to IV. So this is I is your I am sine omega t minus pi by 2, and V is your Vm sine omega t. So here this will be Vm Im sine omega t minus pi by 2, so minus common, so this will be cos omega t, so minus cos omega sin 90 minus theta. So here this will be if you take minus common, 90 minus, this will be sin minus cos omega t, and here this will be sin omega t. Now if you, this is equal to Vm Im, this will be minus 2 by 2, this will be sin sin 2 omega t. This is all about trigonometry. Here, because here both your current and IV, so both are fluctuating. So when there is a you have studied already that at every instant your current and voltage are changing. So it is better to go for instantaneous power. So it is better to go for instantaneous power because your current and voltage both are changing with respect to time. So better go for instantaneous power. So your instantaneous power comes here this, and if you take the average of this instantaneous power, so here Vm Im by 2 and average of minus 2 omega t means for sine, for one cycle, remember for one cycle your this will be your average power, this is 0, so your average power will be 0. So here your average power will be. So here this is all about your alternating current, and all about your alternating current. So this is your phasor diagram, and this is your graph, this is your average power, average power is your 0. We are going to take instantaneous. Why? You have to ask why we went for instantaneous power. Because here your current and voltage is changing with the time. So it is changing with time. So we went for instantaneous power, and when we find this instantaneous power, then on we are able to find this average power for one cycle. For one cycle. So you must ask such, why did we go for instantaneous power? Such type of question you must ask, that why here we went for instantaneous power. Why? And then only everything, we can't find power here directly, because it is not a DC current, so that we can find it the power. This is a fluctuating current, fluctuating AC source. So we have to go for instantaneous power, and after finding the instantaneous power, we can go for average power. These are the basics you must learn, you must know. This is trigonometry solving. All this doesn't matter. These are all trigonometry trigonometric analysis. Here, why we go for instantaneous power? These are the questions you must ask. Then only everything will be clear. All the graph will be clear, and you need not have to memorize anything. Now let us go my third circuit. Here my third circuit is. Now let us go for my third circuit. Let us go for my third circuit. My third circuit is with capacitance. My third circuit is with capacitance. My third circuit is with capacitance. Again, your V, that is equal to Vm sine omega t. This is Vm sine omega t. So my capacitance, and you know that Q is equal to CV. So Q by V is equal to C. You know this about capacitance. Here again, here this will be Q by C is equal to V. So here this will be V. So here your, according to your Kirchhoff's law, again according to your Kirchhoff's law, here this is Vm sine omega t is equal to Q by C. This is according to your Kirchhoff's law, and your current I is equal to dq by dt. So from here your Q will be equal to this I. Your Q will be equal to B CVm sine omega t by dt. When you differentiate it, you are going to get that is I is equal to CVm omega cos omega t. So this is I, it will be equal to Vm 1 by omega c, and this instead of cos we can write sine pi by 2 sine 90 plus theta, sine 90 plus theta, that will be equal to cos theta, because second quadrant sine is positive, and here this will be I will be equal to Vm by xc sine omega t plus pi by 2. So here you see that here if you compare this, that means current is ahead of, your current is ahead of V. here this is IM, and this is your current is ahead of V. So your current is ahead of V. Current is ahead of V, so your graph will be, this is your V, and your current is ahead. Your current is ahead of V. So every time you see your current, that is Vm by XC. So Vm by XC. So here this is for V and this is for I, and your phasor diagram will be, since I is ahead, this is I and this is VC, that is your V. I is ahead of V. So this is your phasor diagram, and here XC, your XC is called capacitive reactance. Your XC is called capacitive reactance. Your XC is called capacitive reactance. So now here again, because current and your potential is fluctuating, so we will go for instantaneous power, and here you are going to get Vm sine omega t, and here this is I is equal to this is cos omega t. Here this is C Vm cos omega t. So whatever it is, C Vm square your sine 2 omega t by 2. Now if you go for average, here this average, if you go for average, square by 2, if you go for average, here your average power is, this is 0, so your average power is 0. So your average power is 0. So this is all about, that means you are going to get power only in pure. So this is means I'm again going to repeat the same thing, that is your average power is only for resistive circuit. Your average power is only for resistive circuit. For there is no power for inductive and capacitive for capacitance. So this is the conclusion here we get, and I have tried to make everything clear. Now the last point I am going to do here is that I am going to connect all these three, that is resistance, inductance and capacitance. I am going to connect all these three. I am going to connect all these three, that is resistance, inductance and capacitance. I am going to connect all these three. I am going to connect resistance, inductance and then capacitance. I am going to connect all these three to an AC source. I am going to connect all these three to an AC source. So what is going to happen here? What is going to happen here? I am going directly to the phasor diagram. So here this is very important, and here you see your phasor diagram. In your phasor diagram, that is your resistance. Your resistance, this is V and R and I. This has been considered as the mean reference. This has been considered as the mean reference. This has been considered as the mean reference. Now, if you go for the phasor diagram of say inductance, in the phasor diagram of the inductance, this was your V, L, and this was your I. This was your I. So if we now rotate it and bring this parallel to this, your V will shift here. Your V will shift in this direction. This is VL. Will shift in this direction. Now again, if you go for this capacitance phasor diagram for capacitance, you have found that this is I and this is your VC. Now, if you rotate this makes I parallel to this, then your VC will be this. This is VC. This will be VC. So, we have taken this resistance as your base, and then here we have made this I parallel to this. When I make this I parallel to this, your VL rotates here, and when I make this is for inductance, and this is for capacitance. And if I make this I parallel to this and rotate here this way, so in rotate here like this, so your phasor diagram, the resulting phasor diagram will be like this. Now the question arises. Now here the question, and this is your V is equal to Vm sine omega t. Now your question arises, why VC is length of VC is greater than VL? Why? You must ask such type of why they have drawn like this. So if you go for I, that is for inductance, it is Vm by omega L, and if you go I for this capacitance, this will be 1 by omega C. So here you see that your omega C will come to the numerator. So from here we find that the current in the capacitor is more than the current in the inductance. So current in the capacitance is more than the current in the inductance. So voltage of the capacitance will be more than that of the inductance. So your voltage length is greater than VL. So such type of questions you must ask. Why they have drawn like this? Only just memorizing it. Most of them just memorizing it. They do not ask why this VC is greater than VL. So these are the reasons. So here you see the current in capacitance is more than the current in the inductance. From the mathematically you get it. So current is more. So your potential in the capacitance will be more than that in the inductance. Now the resultant of this is V. So V, resultant of this is V. This is V. This is V. So since V is making an angle omega t with the x-axis, so this must be, because we have in for resistance it was originally V is equal to Vm sine omega t for resistance. For every case it is the same, but since this V is omega t, so here there must be some difference. These two angles must be some phi. So the angle from here to here will be omega t plus phi. So here this is V, this is the resultant. So resultant of this will be this is the resultant, and this will be your Vc minus VL. So this will be your resultant, Vc minus VL. Vc minus VL, and so your V will be, what will be? V will be equal to root over VR square plus Vc square minus VL square. So yeah, we have to apply Pythagoras, because here there will be a right angle, and here this is Vc minus VL square. So such type of questions you must ask. You must be clear. So why omega t plus phi angle for VR? Because here originally it is omega t. This is the result. So we have to keep some angle between this So this we have to take 5 and this is omega t plus 5. And if you go place this value of VR, VC and VL, VC and VL, VC and VL, then VC and VL, if you place this, so your impedance Z will be equal to your R square plus XC square minus XL square, XC square minus XL square. So again here this is the Pythagoras, and since your VR is making phi with V with the resultant, with the result phi, so here again your diagram will be like this. Here this will be 90 degree Pythagoras. So this will be XC minus XL, and here this will be R because your VR is making and with the resultant phi. So this is your resultant Z. So it must make an angle phi. So this is, so it makes an angle phi with the resistance. So here your tan phi will be equal to XC minus XL by R. So this is the main basic, and here I want to stop. I am doing this video to tell all my students that you go for the concept, not you try to why such type of figure, why the length is more than this. You must ask such type of questions. It is no doubt they are not going to be asked in your any examination, but this, if everything is clear to you, you needn't have to memorize anything. On spot you can draw everything, and the time interval for your study will learning this will be decreased, so you can go for further to gain more knowledge. You will have time to gain more knowledge. So these are the main things you must ask. So remember, I am repeatedly telling you all, you try to follow this, not only solving these questions, any type of hard questions you are solving. If you are practicing any time the same type of question and then you are able to solve another question, this is not the matter here. The matter here is that you must be clear with every diagrams and everything which is given in your book, in your textbook. And if you have a good revision of it, if you have a good concept in it, and if you have all the formulas, if you have memorized it and all units are clear to it, then any type of questions on spot you can solve it. So this I want to give to all the students here at this age. I do not want any subscription or any likes from you. I am trying my best to clear all this. So repeatedly I am telling this thing to all of you.